Welcome back to your lecture 1.7. In this lecture, we will be studying about gravitation. From here, the lecture will be starting and it will end after completing acceleration due to gravity, and we will cover relation between G and G, and after completing that, we will be doing mass of the earth capital M, and then we'll be completing this variation of acceleration due to gravity, and that's all. This lecture 1.7 will end up in this area. Coming back to the class, in last lecture I taught you what is principle of conservation of linear momentum. We can say this just by looking at this formula, or we can use this diagram as well, but formula is a bit easier. The law states that final momentum of a system is equal to the initial momentum of the system, and that means momentum of a whole system is always conserved when there is no net external forces applied on the system. And as an actual statement, what you want to write, it states that in the absence of an external force, the algebraic sum of the momentum after collision is numerically equal to the algebraic sum of the momentum before collision. That's the topic what we saw in last lecture, and for today's lecture we will be studying about gravitation. Well, to know more or to think more, you just want to learn 9th class science book where you might have came across this word gravity. uh, as I say the word gravity, all of your mind thoughts must go in a thing which relates us with the earth. We are standing in earth because due to gravity. So what is actually gravity or gravitational force means? And for that question, Newton gave the answer. How he gave? That's the actual question. And he stated a law. The law name is Newton's universal law of gravitation. And using this, we can know more things about gravitational force, gravity, and other things. So, going into the law, this law states that every particle of matter in this universe attracts every other particle with a force. This force is directly proportional to the product of their masses and inversely proportional to the square of the distance between the centers of these masses. The direction of the force acts along the line joining the masses. So it's a bit big law. Let us break it into parts and parts. First line, every particle of matter in this universe attracts every each other particle with a force. So what is first of all matter? Matter is something which have mass and occupies space. Well, there are three types of matter. First one is solid, second one is liquid, and third one is gas. And in recent years, scientists discovered two more new types of matter. They are fourth one plasma, and the fifth one will be Bose-Einstein condensate. These two are new, and it's not necessary to learn in your class, but the rest three, solid, liquid, and gas, are necessary, and this is called as matter. So if there is no matter in a place, then that place is occupied by vacuum. Vacuum means no space. That's all. And I explain what is matter. Every particle of matter in this universe attracts every other particle with a force. So if any body has mass, you take water, it has some mass. If you take air, there is mass, but we can't calculate it because it's very small. But there is mass because air molecules contains atoms, and it's a mixture of atom. So if there is atom, then there is definitely mass exhibiting there. So each and every body which have mass will attract each other. Take example, you're watching your phone, and well, you're watching your phone, so phone have mass, and yourself will also have some mass. What's your weight? My weight, okay, take your weight something. My weight is 62, I guess. Let it be, take your weight. So you have some mass now, and the phone might also have some mass. So you both are having mass, and according to the first line, the Newton is saying that your phone will be attracting you and you will be attracting your phone. That's what Newton is saying in the first line, and he is correct, because earth is having some mass and you are having some mass. So by the way, the earth is giving gravitational pull on you. That's what gravitational force is also called. Then this force is directly proportional to the product of their masses. So what is product? First of all, product means 1 into 2, something which is multiplied, and the answer what we are getting is called as product. So mass, product of their masses means mass of the mobile into mass of you. That's called the product of masses. And he is saying that that force is directly proportional to the product of their masses. So if you increase your phone's mass, the gravitational pull between you both will be increasing. If you increase your mass, the gravitational pull between you and your phone will be increasing. That's what directly proportional meant here. And inversely proportional to the square of the distance between the centers of these masses. So first we saw that directly proportional to the product of masses, and here again Newton is saying that the distance between you is inversely proportional to the force acting. So if your phone and you are going away from each other, the force of attraction which is created by gravitation will be also reducing. So if distance increases, force decreases. That's what Newton says here. I am sorry for the disturbances. My screen is I guess my phone is in power saving mode, so the screen text sorry, the screen actually gets darker if it took some time without any disturbance. Don't mind it, just leave that. Fine, continuing with the law. Distance between the center of these masses. Why he's mentioning center of these masses, we need to see. Here take this ball as an example, and take this ball as an example, m1 m2. So there is center here, and for m2 the center is here. And how we need to measure the distance between two objects, that's what he is saying there. See, some of you might be measuring the distance between these two masses from here to here, or some might be measuring from this point to this point, and it actually creates some problem to the scientific researches and some other thing. So Newton said that always consider the center of a body, of these two bodies, and just measure the distances. That's what he said here, and he mentioned it over here also. Then the direction of the force acts along the line joining the masses. So where is the line joining the masses? Actually we need to first know one thing. From this center to this center, if we draw a line, that is called as line joining the masses. Okay, let me do one thing. See, I'm sorry, this is a line actually, or you can take it as a floor, and I'm going to keep a big ball, and there is a small ball over here, and here it is the center, and here it is the center. So they asked for, where is that line joining the masses. So this is the line joining the masses, and if we need to know what is the direction of attraction, this is the direction of attraction. The line through which two centers are joining is called as it's a bit confusing here. Line joining the masses, we can take something else. Physics is up to us, man. Just think and find the solution. This is the line joining the masses. So through this line, or this line acts as the direction which gives gravitational pull or gravitational force or something else. In this way these two masses attracts each other. But if you see in this case, the ball is like somewhat like this. The line of joining of masses is actually parallel to the ground. That's why the force is also coinciding with each other, parallel. That's all. I think so you can get this law. If you can't get that, please comment it. I will do another video for it in Tamil. Better. Explaining anything in Tamil is very easy. Explaining something in English is a lot of tough. We need a good grammar for it. Okay, these things apart. Force between the masses is always attractive and it does not depend on the medium where they are placed. So force, they are mentioning it as gravitational force here. Force between the masses is always attractive. See, if you take a bar magnet or two bar magnets and there is north pole, south pole, you know well. If north pole and north pole are kept close to each other, they repel, and north pole, south pole kept, they attract. So there are two types of reactions or action going on there, that is repulsion and attraction. But in this type of force, gravitational force, they said that there is only attractive force. You can't see anywhere that earth and earth or repelling. Actually, if asteroid comes in, it always attracts. I mean, the earth always attracts the asteroids, it won't repel at all. That's what they are saying here. And it does not depend on the medium where they are placed. So what they are saying here is that if you think that these two balls are kept in a tub or some vessel, and it is filled with water overall, this is better. Okay, water, and the force acting in this mass and the force acting in this mass won't change. The same force will be there also. F1 will be in water also, F2 will be the same in water also. There will be no change if the medium between them is filled with water, gas, hydrogen, lithium, beryllium, let it be anything, the force won't be changing. That's what they said in this paragraph. Then here comes a good derivation. See, I explained a law with in last lecture I explained that final momentum of a system is equal to initial momentum of the system. That's just written in one line, just a formula, m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. That single formula can derive you the whole statement of the law. The same is here. This single formula can state you the big law. Very simple. See what they wrote. Force is directly proportional to product of masses, and it is inversely proportional to the square of the distance between them. R is distance between them, and here square is written. If you can't see it clearly, take your textbooks. Refer your textbooks. I'm sorry. That's all. That's all the law. See, every particle of matter in the universe attracts every other particle with a force. This is a normal statement, and after this, the main law comes in. This force is directly proportional to the product of their masses. Well, yeah, that is the product of their masses. And where is that Andaman? And inversely proportional to the square of the distance between them. That's all. That's enough. That is some unnecessary things. So here they gave us F is inversely proportional to 1 by r square. That's called as inversely proportional to. R is distance between them. This is just a two-line statement which you need to write. If they ask derive the formula for gravitational force, you need to write this thing and you need to derive this formula. That's all. And this thing we are taking it from the law. F is proportional to the product of masses, and F is inversely proportional to the square of distance between them. And we are going to combine these things and we are going to write it as F is directly proportional to this value. To remove this directly proportional symbol, we are going to use a proportionality constant. We used this proportionality constant in before lectures. I don't know where, but we used the letter K. and we wrote k is equal to 1, so we removed k. And but here, after doing many researches, Newton did many researches. He took many mind-blowing experiments, and after doing these things he found that g value is not 1, and the actual g value is 6.674 into 10 power minus 11. This is the unit of g value. And for doing some word problems, doing some numerical problems in this chapter, you need to remember this value is very very important for you, and it is going to help you in your NEET exam or your JEE main exam, JEE advanced exam. If you don't remember this, then don't ever think about NEET or JEE exams. G is called as universal gravitational constant. You need to remember this name also, universal gravitational constant, that is capital G. Small g is called as acceleration due to gravity. We will be doing this now within a few minutes. See, what I want to say is that g is a type of constant and it is named as universal gravitational constant. If you come to 11th and 12th, something like permittivity constant, permeability constant, or Rydberg constant, gas constant, many types of constants are there, and for each and every constant there is some values like this, and you need to remember those values also, and you need to do more and more sums. And what I want to say is that in 11th and 12th, physics is the toughest subject which you will be doing it. Physics is max actually in 11th and 12th. It's interesting also, but you can say that. Okay, winding up with this law, F is equal to G m1 m2 divided by r square. Very important law, remember this. I'm sorry, it's a formula, remember this. Then acceleration due to gravity, small g. This is a bit interesting topic because this small g is closely related to our earth. Going with it, when you throw any object upwards, its velocity ceases at a particular height, and then it falls down due to gravitational force of the earth. Okay, see, I think so you have played high throw using a cricket ball or something. So if you are going to throw it in a high speed from ground to the sky, and it will be reaching some highest point in the sky, and at that point the velocity of the ball will be zero. For a very less interval of time, that velocity of the ball will be zero. So it is decreasing in its way, the velocity of the ball is decreasing in its way, right? And then after reaching the highest point, it is going to increase its speed and going to hit the ground. So from it is go I'm just blabbering like something, I'm sorry for it. Okay, you are going to throw the ball with 40 meter per second velocity, and it is going to reach the sky and the topmost point with the velocity 0, because it's going to rest in the sky for a small interval of time. So the velocity at the topmost point is 0, and after that it is going to return to the earth, and at that point or at the surface of the earth there is some velocity obtained by the ball. And how is that velocity obtained? That's what our question is here. So the answer is gravity. We all know that. So I already told that we need acceleration to change an object's velocity, right? From 50 meter per second to 0 meter per second, retardation is taking place, and from 0 meter per second to 50 meter per second, acceleration is taking place. That's why velocity is changing from 0 to some other velocity. See, one thing you need to know, the initial velocity by which you are going to throw, that is 50 meter per second, will not be equal to the final velocity which the ball is going to hit the ground. It may vary. I am not sure that it may vary. I am just saying it may vary, and sometimes it may be equal. That's not a problem. It may vary. That's what I want to say. and this acceleration from 0 to some point is done by gravity, and that gravity is called as small g, and this small g is not a force, it's an acceleration. Okay, the velocity of the object keeps changing as it falls down. This change in velocity must be due to the force acting on the object. So what is that force acting on the object? Gravitational force, right? Okay, the acceleration of the body is due to the earth's gravitational force. Yeah, I said that. So it is called as acceleration due to gravitational force of the earth. Since the earth gravitational force is acting on the ball, and it is making the ball to get some acceleration. Wait a minute. See, take this as a building. You are going to drop the ball from here, and as it is going to drop, the initial velocity will be 0, because you are just going to leave the ball and the initial velocity will be 0. And then while coming down, actually the ball will going to increase its speed. Why? It is due to gravity which is given by the earth. Since the earth is going to give the force to the ball, right, earth is going to give the force to the ball and it is going to change the speed. So there is some acceleration given to the ball, right? That acceleration given to the ball is called as acceleration due to gravity, and its value is something like 9.8 meter per second square. That's all. So it is called as acceleration due to gravitational force of the earth, or acceleration due to gravity of the earth. It is represented as small g. Capital G is universal gravitational constant. It is a proportionality constant, and its value is given as something a very lesser value. And here small g is acceleration due to gravity. There is differences between capital G and small g. Remember it. It's very much important, and I guess in your exam you will be getting state the differences between capital G and small g. You need to write some differences between it. Learn it and write it. Don't just mug up. Mean value of the acceleration due to gravity is taken as 9.8 meter per second square. Why it is taken as meter per second square? Because small g is acceleration which is given by earth. That's why it is taken as meter per second square. Actually meter second power minus 2 you must spell it, but we can spell it as meter per second square also on the surface of the earth. Okay, this means that the velocity of a body during downward free fall motion varies by 9.8 meter per second for every 1 second. So what they are saying is that if you gonna leave the ball from 0 velocity, within 1 second the ball will attain a velocity of 9.8, and after the 1 second the velocity will increase to 9.8 plus 9.8. Where is it, man? Okay, here the velocity is 0. So after reaching this point, I mean time is 1 second. It has gone 1 second. So after reaching it, the velocity will be 9.8, and after reaching this point, 2 second. From here it took 2 second to reach this point. So we will be adding 9.8 plus 9.8 is 0.61. 9 nines are 18. I'm sorry, 9 into 2 is 18. And then 19.6 meter per second is its velocity in this region. And simultaneously after 1 second it will reach here, that is 3 second. Then again 9.8 will add with 19.6 and the new velocity will be obtained. In such a way the velocity is increasing second by second. That's why they are saying it as meter per second square. However, the value of g is not the same at all points on the surface of the earth. Why? We need to see the law again. See, F is inversely proportional to r square. So if distance increases or decreases, the force will change. Since the force will change, What is the formula of force? Mass and acceleration, right? So if force is going to change, then acceleration will also change. So simple. We just need to remember all the formulas, man. F is directly proportional to mass into acceleration. So A will be changing it. A will be changing if force is changing. That's all. Uh, Due to shortage of time, I'm just stopping this lecture in this part, and I will be continuing the next lecture from relations between small g and capital G, and I will be completing mass of the earth, and I will be doing this one, and I will be doing this one in the next lecture. I'm sorry for the inconvenience. Just go through the book once and you will learn everything. Thank you.